Hello students, this is Miss Dalton and this is video 5.2b, solving linear quadratic systems of inequalities graphically. Let's just go ahead and jump into an example here. In our first example we have y is less than x plus 2, and then we have y plus 2x is greater than or equal to negative 4. These are both linear inequalities, so this is going to be an example of two linear systems. Okay, and so one thing that we're going to need to know when we're graphing is whether or not we're going to make it a solid or a dotted line. And so hopefully you remember that if you have a less than or a greater than symbol, then this is going to be a dotted line. And if you have a less than or equal to or a greater than or equal to, then you will have a solid line. Okay, so in order to graph a linear function, the first thing that we have to do is we have to get y by itself. In this first example, we do have y by itself, so I'm going to graph that one in green. So let's go ahead and graph that, and so to do that we need to use our slope-intercept form. So we have y is less than x plus 2, that's going to have a y-intercept of 2, so we're going to plot that first. And then our slope is just 1 over 1, so we're going to go up 1 over 1, put another point, up 1 over 1, up 1 over 1, and we can continue that all the way through the graph. And then at that point we want to decide, is it solid or dotted? Well, it is a less than symbol, so that is a dotted line. So I'm just going to fill this in and just make it a dotted line. And put arrows on both ends. Okay, now we're going to shade, and so what this is saying is it's all the y values that are less than the x plus 2. So to graph less than, we want to make sure that we shade below, so we're just going to shade lightly below this line. And now we're going to look at the second line. So to do this one, we need to make sure that it is in slope-intercept form. I'm going to do this one in blue. And so we have to get our y by itself. In order to get y by itself, we would have to subtract 2x to the other side. And then we want to make sure that we write it in slope-intercept form. So we're going to have y is greater than or equal to, put the negative 2x first, and then the minus 4. So that we can recognize, okay, this is my slope and this is my y-intercept. And so we're going to make sure that we begin with our y-intercept at negative 4. So we're going to go over here to the graph and we're going to put a point at negative 4. And then our slope is negative 2. So that is negative 2 over 1, so we're going to go down 2 and to the right 1. We'll do it again, down 2 to the right 1. And we can also go from the y-intercept, we can go up 2 and to the left 1, up 2 to the left 1, up 2 to the left 1. And if you continue that pattern all the way through the graph, it makes it a lot easier to graph the line. Okay, and this particular line is greater than or equal to, and so that's going to be a solid line. And greater than or equal to is going to shade above the line. And so we can see that our double shaded area, or our solution, is going to be where in this double shaded area. Okay, so it's all of this right here. So another question that I could ask you is, I could ask you if a point is a solution. And so if I asked you if the point, if I asked you if the point 40 is a solution, then you could say, yes, 40 is a solution because it is in that double shaded area. Okay? What if I asked you if the point 0, -4 is a solution? 0, -4, is that a solution? Well, 0, -4 is on the solid line, and because that is a solid line, then yes, that is going to be part of the solution. If the point was on this dotted line over here, so if I chose that point right there, that 2, 4, 2, 4 is actually not a solution because it's landing on that dotted line. So the dotted line, if it lands on the dotted line, it is not a solution. All right, moving on to example 2. Now we have a linear and a quadratic. So we're going to plot the quadratic first. Y is less than or equal to x squared minus 7. So the first thing we're going to do is we're going to show our vertex. So I'm going to put this one in blue. So our vertex is at 0, -7. So we're going to plot that first. 0, -7. Okay, then I would pick a point on either side of that. So let's go to the right. So if I pick a value of 1, let's plug that in and let's figure out what the y value is on just if it was the equation. So we'd have y equals 1 squared minus 7. So 1 squared is 1, 1 minus 7 is -6. So this would be at the point 1, -6. Okay, so we can plot that point as well. Since 0, -7 is our vertex, then it's going to have a symmetrical point at -1, -6. Okay, then if I plug in another point, let's say I plug in 2. So plug in 2, so y equals 2 squared minus 7. 2 squared is 4, 4 minus 7 is -3. So our y value is equal to -3 when x is equal to 2. It doesn't really look like a 2, does it? So 2, -3 would be here. And remember, it is going to have a symmetrical point at -2, -3. So we can go ahead and graph our quadratic. Now, because it has a less than or equal to, then this is going to be a solid line. And then we want to shade where it is less than. So if I put my pen on my quadratic and I shade less than, then that's going to be this side of it, all below that quadratic. Okay, let's go ahead and move on, and now let's graph the line. The line I'm going to graph in red, and so remember that for your line, this represents your slope. This represents your y-intercept. So we're going to start with our y-intercept at 3. And then we need to go down 2 and over 1, down 2 over 1, down 2 over 1, and then keep going. I can also go up 2 to the left 1. Okay, this is a greater than, so this is going to be a dotted line. And greater than shades above. So I'm going to shade above the line. And so now you can see where it crosses or where it overlaps. So it's going to be this section in here. And so any point that is in this shaded region is a solution. All right, short and sweet video today. Make sure that you understand how to graph and come to class with any questions that you have.